Hi everyone, welcome to this GCSE Higher Revision video. There's 29 days to go into your GCSE Maths exam, so keep up with hard work, you're doing really well. Today we're going to do our first of our two sessions on functions. So today we're going to look at composite functions, and if you've got the Corbettmaths revision card number 32 is going to be a useful one for you on composite functions. So today we're going to look at composite functions, and tomorrow we'll look at inverse functions. And I've just split them up that way, just so that we can do a bit of practice on one of them, then do a bit of practice on the other one, and both of them tomorrow. So just split functions up because it's quite an important topic, and it's one which I would say, the more practice you do on functions, the better. So in this video, we're going to go through composite functions. So let's get started.
Hi, today we're going to be looking at composite functions. So before we actually start looking at composite function, I thought we'd just look at some function notation. So here we've got two functions. We've got f of x is equal to 2x plus 1. So that means we've got a function of x which is 2x plus 1. So in other words, if we know the value for x, what we do is we then multiply by 2 and add 1 to find f of x. In terms of g of x, that's another function of x, g of x, and it's x squared plus 5. So if we know the value of x, if we wanted to work out what g of x is, we do the x value squared and then plus 5, and that would tell us g of x. So here we've got some questions. I want you to pause this video now and I want you to work out what f of 3 is, what f of minus 4 is, what g of 0 is, and what g of 8 is. So feel free to press pause and to work those out. Okay, so if I wanted to work out f of 3, what that means is that x is equal to 3. So I'm going to substitute 3 into the function of x. So I'm going to do 2 times x plus 1. So 2 times 3 plus 1. So 2 times 3 plus 1. And 2 times 3 is 6 plus 1 is 7. So that means that f of 3 would be equal to 7. And that's it. And if you got that, well done. Okay, next, f of minus 4. So that means x is equal to minus 4. So we're going to do 2 times x, so 2 times minus 4. So 2 times minus 4, and then plus 1. Now, 2 times minus 4, that's going to be minus 8. Plus 1 means go back up 1, so that'll be minus 7. So that means that f of minus 4 is equal to minus 7. And if you got that, well done. Okay, now g of 0, so that means that x is equal to 0, so you're going to substitute 0 into g of x, so that means it would have 0 squared plus 5, and 0 squared plus 5 would just be 5, and if you got that, well done. And finally, g of 8, well, that means that x is equal to 8, so we're going to substitute 8 into this, so we're going to do 8 squared, so 8 squared plus 5, and that means whenever we work that out, 8 squared is 64, plus 5 would be 69, so that's equal to 69, and if you got that, well done. Okay, so as we've just seen, if we've got a variable x, we can apply a function g to it, and we would get g of x. And then we could apply another function to it, f, and we would get fg of x. Now, rather than applying two functions, g and then f, we could apply a composite function, fg, and that would bring us straight from our variable x to fg of x. So let's have a look at how we find those composite functions now. Okay, so let's have a look at part of the Corbettmaths revision card. So we're told that f of x is equal to 2x plus 1, and g of x is equal to x squared plus 5, and we've been asked to find fg of x. So in other words, the composite function. So rather than applying the function g and then the function f to find out what fg of x is, what the composite function would be. So to do that, well, if we have x to begin with and we apply the function g to begin with, we would then get x squared plus 5. And then we would apply the function f. So what we're going to do is, well, if we know we start off with x and we apply the function g to it, we get x squared plus 5. We then take our x squared plus 5 and we just substitute that in for the value of x in our f of x. And so that means that fg of x would be equal to, instead of 2x plus 1, it'll be 2, and then in brackets, x squared plus 5, close brackets, plus 1. So we've just replaced the x in f of x with x squared plus 5. And the reason is we start off with x, we're going to apply g of x to begin with, that gives us x squared plus 5, and then we get that answer, and then we substitute that into f of x, and then that means instead of being 2x plus 1, it's going to be 2, and then in brackets, x squared plus 5, close brackets, plus 1. Now we just need to expand our brackets, so fg of x would be equal to, expanding our brackets, 2 times x squared would be 2x squared, and 2 times 5 would be 10, so plus 10, and then we've still got our plus 1, and then if we simplify this, we get fg of x would be equal to 2x squared, and then we've got 10 plus 1, which is 11, so plus 11. So that means our composite function would be 2x squared plus 11, and that's it. So what that means is, rather than applying function g and then function f, we could apply this composite function, and it'll bring us straight from x to fg of x. And that's it, that's our answer, that's our composite function. And let's just show this works. So for instance, if we wanted to work out fg of 3, well, that would be equal to, if we substitute 3 in for x here, we would get 2 times 3 squared plus 11. Remember Corbettmaths, we have to square first. 3 squared is equal to 9, times 2 is equal to 18, so we're going to get 18 plus 11, and 18 plus 11 is 29. So fg of 3 is equal to 29. Now if we go back, if we apply function g and then function f, we'll get fg of x. So let's just check if we apply function g and then apply function f, will we get the same as fg of 3. So if we substitute 3 into g of x to begin with, we would get 3 squared plus 5. 3 squared is equal to 9 plus 5 is equal to 14. So that means that g of 3 is equal to 14. Now we're going to substitute that into f. So we're going to do the for f of 14, and that would be 2 times 14 plus 1. And 2 times 14 is 28, plus 1 will be equal to 29. So as you can see, if we apply function g and function f, that's the same as just applying this composite function fg of x, and that's it. Okay, let's have a look at another question. Okay, so this time we've got the same functions. We've been given f of x is equal to 2x plus 1 and g of x is equal to x squared plus 5. But this time we've been asked to find gf of x. So in other words, we're going to apply function f first of all and then function g. Okay, so if we start off with x and we apply function f to it, well, that would give us 2x plus 1. Then we're going to apply function g, so we're going to replace the x in function g with 2x plus 1. So gf of x would be equal to, instead of x squared plus 5, it's going to be 2x plus 1 squared plus 5. So we replace the x with whatever we're substituting in. So that would be, if we work this out, well, let's write the bracket out twice. We're squaring it, so 2x plus 1 2x plus 1 and then still plus 5. Let's expand our brackets. So 2x times 2x would be 4x squared. 2x times 1 is plus 2x. 1 times 2x is plus 2x, and 1 times 1 is plus 1. And we've still got our plus 5. And then if we simplify this, we'd get 4x squared. 2x plus 2x is plus 4x, and then 1 plus 5 is plus 6. So that means that gf of x is equal to 4x squared plus 4x plus 6, and that's it. Okay, let's have a look at some for you to try. Okay, let's have a look at some questions for you to try. So we've got f of x is equal to 2x minus 1 and g of x is equal to x plus 8. So can you press pause now and find fg of x and gf of x? Okay, so if I wanted to find fg of x, we're going to apply function g first of all. So if we start off with x and we apply function g, we'd get x plus 8. And then we're going to apply function f, so we're then going to substitute this into function f. So that would give us fg of x would be equal to, instead of 2x, we're replacing the x with x plus 8, so it's going to be 2 bracket x plus 8, close brackets, and then minus 1. And now if we expand our brackets, 2 times x would be 2x. 2 times 8 would be 16, so plus 16, and we've still got our minus 1. And then if we simplify this, we'd have 2x, and then we've got 16 take away 1, that's going to be plus 15. So that means that fg of x would be equal to, fg of x is equal to 2x plus 15. And if you got that, well done. Okay, now let's have a look at finding gf of x. Okay, so in terms of gf of x, well, we're going to apply function f to begin with. So if we start off with x and we apply function f, we get 2x minus 1. And then we're going to apply function g, so we're going to substitute this into function g. So instead of writing x, we're going to write 2x minus 1. So that means that gf of x will be equal to, instead of x, we're going to write 2x minus 1, so 2x minus 1. And then we've got plus 8. So we're just adding 8 to this, so that would be, we've got 2x, we had minus 1, and we're adding 8, so it's going to be plus 7. So that means that gf of x would be equal to 2x plus 7. And if you got that, well done. Okay, let's have a look at another question for you to try. So we've got g of x is equal to 2x minus 3 and h of x is equal to 5 minus 2x. So can you find hg of x and gh of x? So feel free to press pause and try this now. Okay, so in terms of finding hg of x, we're going to apply function g first of all. So we've got x, we apply function g, we get 2x minus 3. Then we're going to substitute that into function h because we then apply function h. So let's substitute that in for the value for x here. So that would give us hg of x would be equal to 5 minus 2, and then in brackets, and then we're replacing the x with this, so 2x minus 3, close brackets. Now we need to expand our brackets, so we've got 5. Then we've got minus 2 times 2x, that's going to be minus 4x. And then we've got minus 2 times minus 3, that's going to be positive 6 or plus 6. And then if we simplify this, we've got 5 plus 6 is 11, and then we've got our minus 4x. So we've got that hg of x is equal to 11 minus 4x. Okay, next we want to find gh of x. So we're going to apply function h first of all, so we've got this, and then we're going to apply function g. So we're going to substitute this into g. So then that would give us 2, and then replacing the x with this would be then in brackets 5 minus 2x, close brackets, and then we've got our minus 3. 2 times 5 is 10, and 2 times minus 2x would be minus 4x, and then we've still got our minus 3, so minus 3. And then if we simplify this, 10 minus 3 is 7, so we then get 7 minus 4x, and that's it. So gh of x would be equal to 7 minus 4x, and that's it. And if you got those, well done. Okay, let's have a look at our next question. Now sometimes, rather than being asked to find fg of x or gf of x or even gg of x and so on, what you might be asked to find is actually things such as fg of 2 or gf of 1 or gg of minus 2 and so on. So if you want to work that out, one way you could do it is to find the composite function and then substitute in 2. Or another approach is to apply function g, so get x equals 2, apply function g, get that answer, and then apply function f, and then you'll get fg of 2. And you could do the same for the others as well. So you can either get the composite function and substitute then in 2, or get this composite function, then substitute in 1, or get this composite function and then substitute in minus 2. Or you could just let x equal 2 and apply function g, get that answer, and then apply function f. You could let x equals 1, apply function f, get that answer, and then apply function g. And in this case, let x equals negative 2, apply function g, get that answer, and then apply function g again. So it's up to you which approach you want to use. So press pause now and work these out. Okay, so I'm actually going to do both approaches. I'm actually going to start with the composite function ones, just so I can get my composite functions to begin with. So if I wanted to find fg of 2, what I could do is I could find fg of x, so fg of x. So let's find fg of x. So I'd let x, so I start off with x, I'd apply function g, so it would give me this, and then I'm going to substitute that into function f, because we're then applying function f. So I'm going to replace the x with 4x minus 3. So instead of writing x, I'm going to write 4x minus 3, and then I've still got r plus 6, and then that would be 4x plus 3. So that means that fg of x is equal to 4x plus 3. Okay, so that'll come in handy whenever we do this question. And let's actually find gf of x as well. So gf of x. So in terms of finding gf of x, I would start off with x. I'd apply function f, so that'll give me x plus 6, and then I'm going to substitute that into g of x to find gf of x. So if I replace the x with x plus 3, that'll be 4, and then brackets, x plus 6, close brackets, and then minus 3. 4 times 6 is plus then 24, and then we've got our minus 3, so that'll be 4x plus 21. So that means that gf of x equals 4x plus 21. And for this one, it'd be handy if we had gg of x. So if I wanted to work out the composite function gg of x, I would start off with x, I'd apply function g. Okay, so if I wanted to work out gg of x, I'm going to start off with x, I'd apply function g, that'll give me 4x minus 3, and then I'm going to apply function g again, so that means I'm going to replace the x in the 4x minus 3 with 4x minus 3, so it'll be 4 bracket 4x minus 3 close brackets minus 3, replacing this x with 4x minus 3, and then expanding our brackets we give us 16x minus 12 minus 3, so that'll be 16x minus 15. So gg of x equals 16x minus 15. So we've got our three composite functions. Now you might not actually have used those. I'm just going to show you that both approaches would work here. So one approach is if I wanted to find fg of 2, what I'm going to do is just replace the x in this composite function with 2. So fg of 2 would be equal to 4 times 2 plus 3. So 4 times 2 plus 3. And 4 times 2 is 8 plus 3 is 11. So that'll be equal to 11. Okay, next one, gf of 1. So let's look at our composite function, and we're going to let x equals 1. So that means that gf of 1 would be equal to 4x. That's going to be 4 times 1 plus 21. 4 times 1 is equal to 4, plus 21 is 25. So that would be 25, and if you got that, well done. And finally, gg of minus 2. So we've got our composite function. We just need to let x equal minus 2. So we've got gg of minus 2 would be equal to 16 times x. That's going to be 16 times minus 2 minus 15. So 16 times minus 2, that's going to be minus 32. And then we've got our minus 15, so that would be minus 47. So that means that gg of minus 2 is equal to minus 47, and that's it. So we've got our answers. That's one way to do it. Now there was another approach. Rather than doing the composite functions, you could have used a different approach where you start off with x equals 2, apply a function g, and then get that answer, and then apply function f. And I'm actually going to use those approaches now as well. So I'm actually just going to get rid of these for the minute. Okay, so if we wanted to work this out, we're going to let x equals 2 and apply function g first of all. So we're going to find g of 2, and that's equal to 4 times 2 is equal to 8, minus 3 is equal to 5. So we've got that's equal to 5. Now we're going to apply function f, so we're going to then substitute 5 into function f. So we're going to do the f of 5 would be equal to 5 plus 6 is equal to 11. So we've got that's equal to 11, and that's equal to 11, and that's what we had before. That's fantastic. Next, if we wanted to work out gf of 1, we could substitute 1 into function f to begin with. So f of 1 would be equal to 1 plus 6 is equal to 7. And then we're going to apply function g. So then we're going to let x equal 7. So we're going to get g of 7 will be equal to 4 times 7 minus 3. And 4 times 7 is 28, minus 3 is 25. So that's equal to 25. And this is actually a bit easier in terms of doing the questions rather than getting the composite functions. But it might be that you have to do that in part A, and then if you've already got it, you may as well use it in part B. Okay, and finally, GG of minus 2. So in terms of that, let's let x equals minus 2. So we're going to do 4 times minus 2 minus 3. 4 times minus 2 is minus 8, minus 3 is minus 11. So we've applied g once, now we need to apply it again. So we're going to do g of minus 11, and then that would be 4 times minus 11, then minus 3. 4 times minus 11 is minus 44, minus 3 would be equal to minus 47, and that's it, that's equal to minus 47, and that's it. And if you got those, well done. Okay, let's have a look at another question. So this time we're told that f of x is equal to 2x plus 7 and g of x is equal to x minus 3. And we're given that g f of a is equal to 2, and we've been asked to find the value of a. So feel free to press pause and try this now. Okay, so what I'm going to do is I'm going to start off by finding the composite function. I'm going to find g f of x to begin with, okay? Okay, so to find g f of x, what we'll do is we'll start off with x and we'll apply function f to begin with, so we get 2x plus 7, and then we'll apply function g. So let's replace the x with 2x plus 7. So that would give us 2x plus 7 minus 3. So just replacing the x with 2x plus 7. Now, if we then take away 3, we'd get 2x plus 4. So we've got g f of x is equal to 2x plus 4. So we've got the composite function, we've found that g f of x is equal to 2x plus 4. Now we're told there's a particular input a, and whenever we substitute it into the composite function, or when we apply the composite function, we get an answer of 2. And we've been asked to find the value for a. Okay, so let's start off with a and let's apply the composite function. So if we apply the composite function, we find g f of a, well that would be, instead of x we would have a, so that would be 2a plus 4. That's what we get if we apply the composite function to a, we get 2a plus 4. But we're told it's equal to 2. So let's then let this equal 2. So let's write 2a plus 4 equals 2. And let's just solve this and find out what a is. And that'll be our answer. So if we take away 4 and take away 4, we're going to get the 2a equals minus 2. And then if we divide by 2, we get a is equal to minus 1. So it means that a is equal to minus 1. And that's it. And let's just check that. If we actually substitute in minus 1 into our composite function, do we get an answer of 2? So 2 times minus 1 is minus 2. Plus 4 is equal to 2, and that's it. Okay, let's have a look at another question. Okay, let's have a look at our next question. So our next question says f of x equals x squared plus 1 and g of x equals x plus 4. And we've been told that f g of a equals 122, and we've been asked to find the values of a. So find the possible values for a. So obviously values, there's going to be more than one of them. So feel free to press pause now to try this question. Okay, so I'm going to find the composite function to begin with. So in terms of our function, we're finding fg of a. So I'm going to find the function fg of x. So to find fg of x, I'd start off with x, I'd apply function g, so that's going to be x plus 4. And then I'd apply function f. So if I replace the x in this with x plus 4, that'll be x plus 4 squared and then plus 1. So let's square this. So write the bracket out twice. So x plus 4 bracket x plus 4. And then we've got plus 1. And then if we expand our brackets, that gives us x squared plus 4x plus 4x plus 16. And then we've still got our plus 1. And then that'll be x squared plus 8x plus 17. So we found the composite function fg of x. And then we're told that fg of a is equal to 122. So in other words, there's particular values of a that whenever you apply the composite function, you're going to get answers of 122. And this says values, so there's going to be more than one of them. So let's substitute in the values for a. So that means that fg of a would be equal to, well, replacing the x with a would be a squared plus 8a plus 17. And then we're told this equal to 122. So let's put this equal to 122. So a squared plus 8a plus 17 is equal to 122. And now we just need to solve this quadratic and hopefully we'll find our values. So let's take away 122 from both sides. So take away 122 and take away 122. And we get that a squared plus 8a minus 105 is equal to 0. And now we just need to hopefully factorize this and solve it. So let's factorize it. So I'm thinking that's going to be 15 and minus 7, because 15 times minus 7 is equal to minus 105. And minus 7 plus 15 is 8. So that's it. So now that means that a is equal to minus 15, or a is equal to 7. And that's it. We've found our values for a, that either a is equal to negative 15 or a is equal to 7. And that's it. There are our values for a. And if you got those, well done. Okay, let's have a look at another question. So this time we're told that f of x is equal to kx plus 6 and g of x is equal to 2x minus 3. And we're told that g f of 1 is equal to 17. And we've been asked to find the value for k. So feel free to press pause now and work out the value of k. Okay, so because it's gf of 1, I'm going to find the composite function gf of x to begin with. So let's find that composite function. So if I start off with x and I apply the function f to begin with, well, if I apply the function f, we would get kx plus 6. And then we're going to apply function g, so we're going to replace the x in function g with that. So that would be equal to 2, and then brackets, kx plus 6, close brackets, and then minus 3. And then if we expand our brackets, that'll be 2kx plus 12 minus 3. And then 12 minus 3 is 9, so that'll be 2kx plus 9. And that is gf of x. Okay, so we found the composite function, 2kx plus 9. Now we're told that gf of 1 is equal to 17. So let's let x equal 1, so that would be gf of 1, and let's see what we get. So we're going to do 2 times k times x. Well, x is 1, so 2 times k times 1 will be 2k, so 2k, and then we've still got our plus 9. So gf of 1 is equal to 2k plus 9. But we're told that's equal to 17. So 2k plus 9 is equal to 17. Take away 9 from both sides, gives us 2k equals 8, and then that means that k equals 4. So it means that k equals 4, and we've done it. We've found what k is 4. And if you got that, well done. Okay, let's have a look at one last question. We've got the f of x is equal to x squared plus 4, and g of x is equal to x minus 6, and we've been asked to solve fg of x equals gf of x. So in this question, we've got fg of x equals gf of x. We want to solve it, so feel free to press pause and to work this out. Okay, so we've got our composite functions. Let's find our two composite functions, fg of x and gf of x. So our fg of x, we're going to start off with x, we're going to apply function g, so that'll give us x minus 6, and then we're going to apply function f, so we're going to replace x with x minus 6. So that would be, instead of x squared, it'll be x minus 6 squared plus 4. So we've got the fg of x is equal to x minus 6 squared plus 4. I'm actually just going to leave it like that at the minute. I'm not going to expand and simplify it yet. I might do it in a minute I might have to in a minute anyway, but I'm just going to leave it like that for the moment. And so we found fg of x. Now let's find gf of x. So gf of x, and let's see what we get. Okay, so we start off with x, we'd apply function f, so that'll give us x squared plus 4, and then we then apply function g, so we're going to replace the x with that, so that'll be x squared plus 4, and then r minus 6, just replacing the x with x squared plus 4. And now we can actually just take away 6, that'll be x squared minus 2. So we've got the gf of x is equal to x squared minus 2, and we've got that fg of x is equal to x minus 6, close bracket, squared plus 4. Now we've been asked to solve when they're equal to each other, so let's put them equal to each other and solve them. So that's going to be x minus 6, close bracket, squared, plus 4, equals x squared minus 2. So let's expand our bracket, so let's write it out twice, so x minus 6 bracket x minus 6, and then we've got our plus 4, and then our right hand side we've got x squared minus 2. Now let's expand our bracket, so x times x is x squared, x times minus 6 is minus 6x, minus 6 times x is minus 6x, and minus 6 times minus 6 is positive or plus 36, and then we've still got our plus 4, and that equals x squared minus 2. Okay, now let's simplify this left-hand side. So we're going to have x squared minus 12x. With 36 plus 4, that's going to be plus 40, and that equals x squared minus 2. Now I want to solve this, so actually let's get rid of our x squared. So let's take away x squared from both sides. So we're going to get minus 12x plus 40 equals minus 2. Okay, now we want to find out what x is, so let's take away 40 from both sides. So take away 40 and take away 40. So we're going to get that minus 12x is equal to minus 2, take away 40 being minus 42. And then let's divide both sides by minus 12. So divide by minus 12 and divide by minus 12. So on the left hand side we'd get x, and on the right hand side we get 3.5. So that means that x is equal to 3.5, and we've solved it. And that's it. And if you got that, well done.
And that's it. So in this video, we've looked at composite functions. Now, you probably don't hear me say this very often. I'm going to put a link in the description below to the practice questions, but don't try them today. Can you try them tomorrow? The reason is with composite functions and tomorrow's lesson on inverse functions, the practice questions or the GCSE questions will often have part A on one of them and part B on the other. And I would say don't do the practice questions today, because if you did them today, you might think, well, I can't remember how to do inverse functions, and we'll look at that tomorrow. I'll put them in the description below anyway, just so you know where to find them. And tomorrow they'll be in the description below as well there. But I would say instead today, do something like your 5-a-days. Do the foundation plus the higher and the higher plus 5-a-days. And maybe just do some other revision, some revision on another topic that you just think you need to do a bit of extra work on. And do the practice questions for those. But that's it. Keep up the hard work. There's 29 days to go to your GCSE Maths exam. One thing I would say is at this point here also is, at this point you're probably doing lots and lots of revision, and you find where works best for you whenever you're doing your revision. I used to like going to the library. I loved going to Belfast Library and doing the revision there and sort of studying, going for the day there if I could. Whenever I was working in, my hometown, I would go to my hometown library and do some work there. But I used to find the library worked really well for me. But also do some revision perhaps if you've got a friend who's studying for the GCSE Maths exam as well. It can be quite useful to do a revision session, one or two of them, whenever you get together with a friend, because you might be able to go through a topic, perhaps histograms, and they might say, well, I would look at these questions in this way. And then you can say, well, I did them this way. And that sort of conversation would be quite useful. Maybe do a past paper together where you say, okay, both of us, let's do question one. You both did it individually. Okay, now let's talk about how did you do it, how did I do it, and so on. So, we're doing some revision with a friend can be quite useful. Now, obviously, do the revision. Don't just meet up with a friend, chat, and then think, oh, we should have done some revision. But working with a friend can be quite useful as well. So try to maybe vary your revision and do it in different ways. And as I said, libraries are a really great place to go and do some revision there on your own, and independent revision. But it can be quite useful to do some revision together with anyone else that you know is preparing for the exam as well. But that's it. So I really hope you found this video useful. I'll see you tomorrow at 3 o'clock for the next one on inverse functions. Cheers. Bye.